And if you're burning about 2.5 tonnes of grass and litter on a place, there's an emissions factor of 0.17. The other issue you have to contend with when I was doing this analysis is what's the fire frequency is going to be. And so there's an issue of regularity in the percentage of property that's burnt each year. You talk to a lot of landholders and they say, oh, we have a fire every year, but when you actually talk to them, they burn a roadside every year, or they burn a little patch over here and a little patch over there each year, but it's usually a pretty small percentage of the property. And I've had a bit of discussion with David and Errol about what fire frequencies will be. So if we assume that one fire in 20 years, averaged out, that'll be 5% of your property gets burnt each year. So that's the type of number I'm looking at. If there was one fire in 40 years, there's 2.5% of the property burnt each year. Interesting though, I looked at the fire scale mapping for the Mr Grass fire region, and in 2007-2008 they had very low area burnt, so I may be overestimating the area burnt on the property. But anyway, using the 5% burnt each year, it's 120 tonnes of carbon dioxide equivalents emitted from the grazed property. So that factors in how much grass is actually on that property. If we go to the destocked property, because there's a higher biomass of grass there to burn, that emissions factor lifts up, so it's gone to 0.29. And again, look, there's a lot of conjecture what's going to be the fire frequency when you destock. I think David said to grow about 700 to 800 kilograms of grass per hectare per year, so that assumes you need 2 years on an average, 2 average years to actually even get to the 1.5 tonnes to actually carry a fire. But good years you get more than that, other years will take longer to get to that stage. So for this analysis I've assumed there's been one fire in 4 years, so 25% of the property burnt per year, which equates to 1,015 tonnes of carbon dioxide emitted from that destocked property. So I'll put all these numbers together so you can have a bit of comparison at the end between the grazed and destocked, so you can add and plus them. But there's a lot of talk about if you burn all the grass, it's just as bad or worse than if you graze it. And so I've actually given you a number there. If you burnt all the whole destocked property in 1 year, you're emitting about 4,000 tonnes of carbon dioxide in that 1 year. But again, it'll take a number of years before you get another burn. And that's the key point. One fire will emit more than your methane emissions from that block of dirt in 1 year, but you're not burning every year, so you've got to actually take that into account. So the analysis is very sensitive to what that fire frequency would actually end up being. Anyway, if we assume that we're burning 5% of our grazing property and 25% of our destock property per year, there's a difference of 900 tonnes of carbon dioxide between destocking and grazing. I'll now move on to looking at the woody vegetation. And for the purpose of this analysis, I've assumed there's 15% of the property has tree cover. And looking at the slats data for this bioregion, they were 14.8 or something %, so that's pretty right on average across this region. And I've assumed that the basal area in the trees, so I've sort of split it up into 5% of the trees is regrowth, 5% gidgee forest type thing, and the rest is just scattered on downs country. The basal area in trees is 4 metres square per hectare. The basal area in the regrowth is about 2 metres square per hectare, and basal area is the area of the butts of the trees essentially on a per hectare basis. And out in the downs I've assumed there's been 0.1 metre square per hectare. So in that case the woody biomass stock would be about 128,000 tonnes of carbon dioxide equivalents on the property. So that's the big bulk of carbon that's sitting in the woody vegetation on your property. So what's actually going to happen to those trees under different management scenarios? I've assumed that there's been no impact from infrequent fire and no clearing, so the very low fire frequency I'm assuming is having no impact, that the trees grow back at a rate that's going to be matched. But I've actually assumed that there's a slow thickening up of the vegetation, and a lot of our research looking at tree monitoring and some aerial photo analysis which the Queensland Herbarium's done, showing that Gidgee encroaching and thickening up. So I've assumed that in the Gidgee clumps the trees are increasing at 0.03 metres square per hectare per year, so pretty slow, but that's what you probably expect in a mature stand. Out in the regrowth it's a lot quicker though, they're probably growing 3 times as fast as that at 0.1. And out in the grassland, even though it's just because they spread out on a per hectare basis, the increase is going to be quite slow. So using those assumptions, the woody biomass change will be about 800 tonnes of carbon dioxide per year. So that's what's being captured by your property, and that's one of the reasons the atmosphere is not as hasn't got as much carbon dioxide in it as it should have, because a lot of it is being captured by natural vegetation and the ocean. So that's part of what's been pulled out of the atmosphere. You need to note though that livestock carrying capacity over time will slowly decrease as your trees are increasing, and that's not accounted in this, so this is a 1-year assessment. And if you were going to actually re-clear that 5% of regrowth on your property, that's actually got a biomass of 16,000 tonnes of carbon dioxide per year. So that's why tree clearing is so important, why they're trying to slow tree clearing up, is because of cutting down trees over, once you multiply it by hectares, it makes a big difference to the budget. But obviously in this analysis I haven't assumed any tree clearing. In the de-stocked analysis, I've looked at, so it's got the same initial tree biomass, and again, what's going to happen to the trees in that scenario? Does the trees stay the same, or does it decrease with fire? So if it stays the same, basically there's no change in the amount of trees. If you assume that fire is going to knock about those Gidgee plants and suckers and some of the regrowth suckers, and you could assume that there's going to be a decline of 30% in the basal area over the next 30 years. Best numbers pulled out of the air, but seem reasonable. So the woody biomass would decline by 1,300 tonnes of carbon dioxide in that scenario. So this is where fire has a bit of a trade-off. It's not about your tree biomass. It's going to you can make a big difference what the outcome is from saying whether de-stocking or not is good. So in the grey scenario, again, there was 800 tonnes sequestered, and de-stocked, assume it's either zero, or if it's fire's going to knock about the trees, it's a quite a large emission. I'll next move on to soil carbon, and there's going to be more talk about soil carbon later on. And in Queensland, there's very little data on soil carbon. And I'll explain the little coloured pictures here. Along the coloured sort of concentric circles, you can imagine there's a perennial grass tussock in the centre of each of those concentric circles. And they actually measure the soil carbon in bands going out from that perennial grass tussock. So in good condition country where your tussocks are big and healthy, you've got a lot of rings, and a high proportion of the area has actually got high soil carbon in it. If you go over to the side here, and that's maybe in C condition where you've still got perennial tussocks, but they've got smaller, they're less healthy, they're further apart. You still get the higher carbon around those individual little tussocks, but it's less, and there's a bigger gaps in between of lower soil carbon. So the theory is, and it makes sense, that the more perennial grasses you have that are healthy, the more soil carbon you have. And that work was done by Andrew Ash as part of the EcoGraze project. So taking some data, there's data looked at the Mitchell grass bioregion, and they estimate there's about 73 tonnes of carbon dioxide equivalents in the top 30 centimetres of soil. So if you actually multiply that up to the property, it ends up to being 1 million tonnes of carbon dioxide equivalents.